What is cardiovascular system? Cardiovascular system, also known as circulatory system, is made up of your heart and numerous blood vessels throughout your body. Your heart uses a vast, complicated network of blood vessels to deliver oxygen and other important nutrients to your entire body. This network also removes waste from your body and transport it to organs that can discard it. Your blood transport oxygen, nutrient, and waste throughout your body. The cardiovascular system function is to ensure that your body receives the oxygen, nutrient, and other substance it requires while eliminating those it does not. Every day, your heart circulates approximately 2,000 gallons of blood. Some blood vessels, such as veins, transport blood to your heart, while others, arteries, transport blood away from it. Your blood vessels also remove waste from your cell, such as carbon dioxide. Blood always travels in the same direction through your heart. Valves along the path ensure that blood flows in the proper direction.
Anatomy of heart. Our heart is the powerhouse of circulatory system, and it is located in front of our chest and slightly behind to the left of our sternum. Let's look inside the heart to see some of the structure. Heart have 4 main chamber, 2 upper chamber which is atria and 2 lower chamber called ventricles. Heart divided into right and left atrium. We have right atrium, right ventricle, left atrium and left ventricle. Heart have 4 heart valves that we need to know. One at the exit of each of the 4 chamber. Existing from right atrium is tricuspid. Existing from the left atrium is mitral valve or bicuspid valve. And existing the left ventricle is aortic valve. Finally, we have the blood vessel. First is inferior vena cava and superior vena cava. Next, we have pulmonary artery. We also have left and right pulmonary vein. Finally, the aortic carries the oxygenated blood away from heart to the rest of the body. This is the layer of heart. Cardiac muscle found only in the heart wall contract constantly to pump blood throughout the body. Heart wall is composed of 3 layers. The thin layer called the epicardium or visceral pericardium forms the outermost part of the heart wall. This layer adheres the heart to the pericardium, a sac of tissue that protects the heart from friction as it beats. Beneath the epicardium lies the thick cardiac muscles of the myocardium. Myocardium is for heart's pumping actions, making powerful continuous contractions possible. Beneath the myocardium lies the endocardium, which forms the innermost layer of the heart wall. The endocardium lines the heart's internal structure and is continuous with the lining of blood vessels that attach to the heart. These 3 layers aid the contraction and relaxation as the heart beats.
Good day to lecturers. My name is Tan Yi from Nutrition. Now we are going to proceed to the anatomy of heart valve, which consists of semilunar valve and also ultraventricular valve. Both of the valves open and close to allow the blood to flow in and out. For the ultraventricular valve, they include tricuspid valve and also mitral valve. For tricuspid valve, is the door between the right atrium and the right ventricle of heart. While for mitral valve, also can be named as bicuspid valve, is the door between the left atrium and the left ventricle of heart. For the semilunar valve, they include aortic valve and also pulmonary valve. Aortic valve is the valve opens when blood flow from the left ventricle to the aorta, while for pulmonary valve, it opens when blood flow out from the right ventricle to the pulmonary arteries. Our heart conduction system is like an electrical wiring of a house. It controls the rhythms and the pace of heartbeat. It includes sinoatrial node and also ultraventricular node. The sinoatrial node is a cluster of cells that are located in the upper part of the wall of right atrium. Its function is to send the signal to make our heart beat. While for the ultraventricular node is a cluster of cells that is situated in the center of heart, between the atrium and the ventricle. Its function is to carry the electrical signal from our heart upper channel to its lowest one. Our heart also has a network of electrical bundles and fibers. This network includes left bundle branch, right bundle branch, bundle of his and also Purkinje fiber. The major blood vessels connected to our heart are the aorta, the superior vena cava, inferior vena cava, pulmonary artery, pulmonary vein, and also the coronary arteries. For your information, the pulmonary artery is to receive the deoxygenated blood from the right ventricle and deliver it to the lungs for gas exchange to take place. While for the pulmonary vein is to receive the oxygenated blood from the lungs and deliver it to the left side of heart and to be pumped back to around the body. That's all for the anatomy of heart.
Good day to lecturers. I'm Li Wei from Year 1 Medical Radiation. I'm going to present the physiology of heart, which is cardiac cycle. The cardiac cycle comprises all of the physiological events associated with a single heartbeat, including electrical events, mechanical events, the pressure and volumes, and heart sounds. The atria and ventricles alternately contract in each cardiac cycle. The pressure in the chambers changes greatly over the course of the cardiac cycle. The cardiac cycle is essentially split into two phases: systole, the contraction phase, and diastole, the relaxation phase. Each of these is then further divided into atria and ventricular component. The cardiac cycle therefore proceeds in 4 stages. The first stage is atrial systole. The cycle is initiated with the firing of SA node that stimulates the atria to depolarize. This is represented by the P wave on the ECG. Atrial contraction starts shortly after the P wave begins and causes the pressure within the atria to increase, forcing blood into ventricles. Atrial contraction, however, only accounts for a fraction of ventricular filling because at this point, the ventricles are already almost full due to the passive flow of blood down the ventricles through the open AV valves. Atrial pressure drops when the atria stop contracting. This stage takes about 0.1 second.
Hello, my name is Syafiatul Fitri and I am from Forensic Science Students. Okay, now let's move to the atrial diastole phase. During atrial diastole, blood enters the right atrium through the superior and inferior vena cava and the left atrium via the pulmonary veins. In the early part of this phase, the atrioventricular valves are closed and blood pools in the atria. There comes a point when the pressure in the atrium is greater than the pressure in the ventricle of the same side. This pressure difference results in the opening of the atrioventricular valves, allowing blood to flow into the ventricle. This phase lasting about 0.7 seconds. We move to the ventricle system. The atrioventricular valves close when the pressure in the ventricles exceeds the pressure in the atria. As the ventricles contract isovolumetrically, their volume doesn't change. The pressure inside increases, approaching the pressure in the aorta and pulmonary arteries. Ventricular systole ejection, semilunar valves open at the beginning of the phase. At first, rapid injection that takes about 70% and remaining is slow injection, 30%. Ventricles continue to contract, which pressure in ventricles exceeds the pressure in aorta and pulmonary artery. Semilunar valves open, blood is pumped out of veins and volume decreases rapidly. Then, pressure in the ventricles falls below the pressure in the arteries. Blood in the arteries begins to flow back toward the ventricles. At the end of ejection, the semilunar valve closes.
Hi, my name is Siti Rabiatul and I'm from Dietetics program. Moving to the next topic, which is ventricular diastole. Isovolumetric relaxation is the early phase of ventricular diastole. During this phase, pressure on the remaining blood within the ventricle begins to fall as the ventricular muscle relaxes. When pressure drops below pressure in both the pulmonary trunk and aorta, blood flows back toward the heart, producing the dicrotic notch seen in blood pressure tracings. The semilunar valves close to prevent backflow into the heart. Since the anteroventricular valves remain closed, there is no change in the volume of blood in the ventricle. As the ventricles continue to relax, the intraventricular pressures will at some point fall below their respective arterial pressures. When this occurs, the AV valves rapidly open and passive ventricular filling begins. Despite the inflow of blood from the atria, intraventricular pressure continues to briefly fall because the ventricles are still undergoing relaxation. Once the ventricles are completely relaxed, their pressure will slowly rise as they fill with blood from the atria. High arterial pressure causes rapid initial flow of the blood into the ventricles. Pressure in the atria and ventricles rises slowly as blood continues to return to the heart, decrease the rate of blood flow from atria to ventricle, and causing a very slow filling called diastasis. 75% of the blood passes from the atria to ventricle during the rapid filling phase and diastasis phase. And I think that's all from me. Thank you.